So, welcome to Manchatmosphere. Today I'm going to have a chat with Professor Geraint Vaughan, who is a Professor of Atmospheric Science at the Centre for Atmospheric Science at the University of Manchester. Welcome to Manchatmosphere, Geraint.
Thank you very much.
Professor Vaughan will have the opportunity to respond to only 5 questions. So, Geraint, what aspects of atmospheric science are of interest to you?
So my field of research is in atmospheric dynamics, which is really how air moves around. That's what I'm most interested in. And of course, air moves around in so many complicated ways. You've got big weather systems, cyclones and anticyclones and things, and jet streams. But on the other hand, you've also got air moving through storms, through thunderstorms. And so I look at how these processes work on all those scales.
What specifically makes your research unique in your field?
We have a particular flavour to our work here in Manchester. We use what we call active remote sensing, which boils down to using electromagnetic radiation, radar and light or LIDAR, to measure vertical profiles of wind particularly, and also things like temperature, ozone, water vapour, things like this. So we develop these experiments here. We use them in field measurements. We install them on aircraft. We get involved with networks of these things with other people, and that gives us a kind of window into some of these atmospheric processes that other people haven't really exploited. So that's our kind of USP in this area.
What methods do you employ to execute your research objectives?
Well, I've mentioned our remote sensing, but we don't just do that. We use whatever we need to use to address the problem at hand. So that could mean a research aircraft, for example. We've done a lot of work with the FAM research aircraft. That could mean flying stuff on balloons, so we've done quite a lot of work using small balloons and flying packages on them. Obviously we do ground-based work, and we also do a lot of modelling. So some problems you've just got to use a model to look at, for example, and other problems you have to use a mixture of measurements and modelling. So yeah, we use a range of tools in our work.
Why is your research relevant in the wider world?
Oh, it's very relevant. Everything is relevant these days, but everybody's interested in the weather, aren't they? You want to know what the weather's going to be like tomorrow. And some of our work on, particularly on cyclonic storms, on fronts, and jet streams, and this kind of work is all aimed at essentially improving the weather forecast, improving the way in which particular processes in the atmosphere are represented in models. For example, a few years ago we did a big aircraft campaign, and we were flying around in cyclones, and we were measuring a lot of cloud particles. So with the rest of the group here, by the way, this wasn't just me. Now this produced a fantastic data set, and we've been using this data set to try and see how models think that these clouds affect the structure of the storms. And we've discovered some quite interesting things in a sense that we've discovered that they're less effective than we thought they would be, but sometimes research takes you in that direction. But that's an example where a project goes all the way from making these special measurements all the way through to effectively improving scientific understanding. And it's a process that can take years.
Finally, I'd like you to give me one exciting fact about your atmospheric research.
Well, there's a lot of excitement in what we do. Flying around in these research aircraft, that's always very exciting. And going to distant parts of the world to do special measurements, it's also a very exciting thing, and I've been very privileged in being able to do that kind of research. But I guess the intellectual satisfaction is in this business of bringing measurements and models together, and in finally seeing an end product, if you like, of here I've learned something about the atmosphere here. I've learned that this process works in this way and not the way that people thought it did. I've learned that, for example, you can take air from very low down in the atmosphere in the tropics, and you can lift it pretty much unmixed all the way up to the tropopause, right at the base of the top of the troposphere, which was not a result that I was expecting when I started on that line of research.
Well, thank you, Professor Geraint Vaughan. It's been a pleasure chatting to you on Manchatmosphere.
Thank you very much, Alan.